Have you ever heard of the Coriolis effect? It's often called a fictitious force, something born from the fact that the Earth spins on its axes. Picture the spinning teacup ride at an amusement park. You're sitting in the whirling cup and you throw a ball straight at a friend standing still outside. Somehow, the ball seems to drift sideways, curving away. But in reality, the ball flies perfectly straight. What's curving is your own point of view, spinning along with the cup. That's why it's called a fictitious force. And believe it or not, the exact same thing happens here on planet Earth. The Earth spins so gently, just one full turn a day, that the effect only shows itself over very long distances and times. The Coriolis effect has no real force pushing objects from the side. Objects just keep moving straight, carried by their own momentum. They only appear to curve because we're the ones riding on a rotating ground. The culprit isn't a force, it's our viewpoint. This is the heart of the whole story.
So why does a spinning viewpoint make things look like they curve? The key is the difference in rotation speed. From here on, instead of the Earth, picture a spinning disk. On the same disk, a point near the center and a point out on the rim travel very different distances in a single rotation. The rim moves much faster.
Now imagine you're standing at the center of that spinning disk and you throw a ball straight toward a friend out on the rim. In the brief moment the ball is flying, your friend keeps sliding forward, carried along by the disk. So by the time the ball arrives, your friend is no longer there. The ball sails right past the target. To someone watching from outside the disk, the ball flies perfectly straight. But to you, riding and spinning with the disk, the ball appears to curve away. The same event, yet where you stand changes what you see. This, right here, is the true nature of the Coriolis effect. Now let's swap that spinning disk for the Earth itself. The Earth is a giant disk that makes one full turn every 24 hours. Just as the center and rim of the disk moved at different speeds, different places on Earth rotate at very different speeds. And what creates that difference is latitude. The equator is the widest part of the Earth. It covers a huge distance in a single day, racing eastward at roughly 1,700 kilometers per hour. As you move toward the North or South Pole, the circle of rotation shrinks and the speed drops lower and lower. Same planet, but the ground beneath your feet moves at completely different speeds. Now, suppose something starts moving north from the equator. That object keeps the eastward momentum, 1,700 kilometers per hour, it had back at the equator. But the land to the north travels eastward much more slowly. So the object runs too far east, drifting to the right of its direction of travel. This drift, piling up and up, is what creates those giant swirls. In the northern hemisphere, moving things veer right, so typhoons spin counterclockwise. In the southern hemisphere, they veer left instead, so the swirl turns clockwise. Typhoons wind opposite ways north and south, simply because the ground beneath them rotates at different speeds in different places. That's the whole surprisingly simple reason. By the way, you've probably seen those videos where someone steps across the equator and a draining sink supposedly reverses the direction of its swirl. Sadly, that is not the Coriolis effect. How you pour the water or spin the basin can create a swirl in any direction you like. In a flow as small and brief as a draining sink, the Coriolis effect is easily overpowered by the shape and momentum of the water. It only truly matters at the scale of typhoons or artillery shells flying over great distances, things that are very large and very long. In fact, to verify it precisely, you need strict experiments, like letting a huge tank of water sit perfectly still for hours. Let's pull it all together. There is no real force bending objects. What bends them in our eyes is our own viewpoint, riding the spinning Earth. The true cause is the difference in rotation speed from one latitude to the next. So objects veer right in the northern hemisphere and left in the southern, and typhoons spin in opposite directions, north and south. That is how the Coriolis effect works. Now, this fictitious force,
a phantom that never actually pushes anything, is, believe it or not, used to measure a car's fuel efficiency. How do you measure any quantity with a force that pushes nothing at all? That surprising mechanism, we'll unravel it slowly and carefully in the next video.
Thanks so much for watching all the way to the end. On this channel, from an engineer's point of view, we dig into the everyday mechanisms around us, the ones you thought you knew, but maybe never quite understood. If today's story sparked even a little curiosity, I'll see you in the next video.